Hello, everyone. This is Dr. Delmar, and we are at our Unit 2 video for lecture materials. As promised last week, I was going to wrap back around to two of the documents that I provided you with some notes and some different solutions. So we'll start there, and then we'll hop into some newer material for this week. A lot of this material, as you're probably finding, is very interconnected and overlaps. So, you're building on that knowledge from week to week. And then, of course, because this is a compressed 4-week class, you very quickly come up to the midterm where you have a comprehensive assessment over 2 units, and then the final, which is also over the 2 units, those final 2 units. And then concurrently to this, you are all working on the college readiness assessment. So I guess my point is that all of these notes are important, and you should really be connecting this material in your work. I did mention about having a math notebook, that I do think it's very helpful to have visuals, especially when you're working on one computer screen and completing your assignments online. I think having these notes hard copy is super helpful. So I thought I would just start with algebraic expression, kind of going back over some of these fundamental concepts. And so I'll walk you through what's available in this document and then the second one from last week before I move into the newer material. So again, we're really laying that foundation to help you build math fluency and really speak the language of math, right? And so what you'll probably notice is with a lot of times with the instructions, it's you kind of have to know what the words mean and the terminology is to be able to even read the instructions and then know what kind of solution that you're coming up with, because sometimes it's not necessarily working the math and coming up with a number, which is what I mentioned last week. Sometimes you're coming up with a solution that's not a fixed number, and so really understanding what those instructions are telling you to do is super important. It not only helps you get the right answer, but it helps you avoid frustration because you might be trying to solve for something that's maybe not possible or not necessary. So that's another reason for knowing the language of math is to understand the instructions and exactly what it's asking of you. This might be a great question on your lecture assignment participation activity for the week about why do you need to know math terminology and how does it help you with reading the instructions, which the answer would be obviously, better what you're intended to do, right? So knowing the intentions of a question, it's helpful for you to know the math terminology. So that just might be a great quiz question for that participation assignment that's associated with your lecture video. All right, so an algebraic expression, it is a sentence essentially. It's a math phrase, and I kind of touched on that last week. And so this is a very simple couple of examples for you. But what I like is in the notes, I've laid out for you not just what it looks like, but also what these mean. So if you have forgotten, for example, 3x means 3 times the value of x. And again, I mentioned last week, sometimes we go really fast into just solving the math and we don't break down what each of these concepts means. So I think this building your confidence is helping. Well, I hope it helps. And so you can see here it just breaks down, for example, 2y minus 7. What are we actually doing? We're subtracting 7 from 2 times the value of y. But that kind of goes back to what we were saying last week too about variables. Like, why are we using variables? So a variable is a placeholder because we don't know the number. So very often you are solving for what x or y is, and it could be any letter, but we just typically use x or y because if you're graphing, we have the x and the y axis. I'm sure you're at least somewhat familiar with graphing. And so we're solving for x or y very often, and that's why we have the x's and the y's. We went into math modeling just a little bit last week. We talked about, like, it kind of reminds you of maybe the word problems from when you were maybe in like middle school. But this is where we stream together the vocabulary and the concepts to be able to solve a real world situation. This one is obviously about something fun like buying concert tickets, but think about the ways this could be used in the health field. And this is just some reasons why we need algebraic expressions. Making predictions and decisions based on the data, that's one that really should hit home to you if you're thinking about the health field. Think about medications and dosages and length of time, pace, and intensity for treatments. That's something that may be a real-world connection for you. And then as you recall, there's a practice problem. So I'm just posting this again because I think this is one of the set of notes that's going to be super helpful for you to be successful throughout the coursework. And then the other one was simplifying expressions with integer exponents. And as you recall, I started with the vocabulary or the academic terminology. And I mentioned to you in my notes, because I'm typing this, I have terrible handwriting, by the way, that when I type this out for you, I put the little upside V, and that just means to the power. So when you see, for example, and I'll go back to this one and show you. Well, there's not one there. But if you can imagine, say, like 3 to the 4th power. So you have the big 3 and the 4 is little tiny up in the top right of the 3. That's when you're looking at exponents. The V is just indicating it's a small 4 because the font is too big. So it wouldn't be 34. You wouldn't want to write 34 because that's not what the indication of this is. It's 3 to the 4th power. So that little upside V is means 3 to the 4th power, and here 2 to the 3rd power. So just imagine that the V wasn't there and the 3 was really tiny and it was right there above the 2. And then here where we talk about power rule, a to the m power, a to the m times n. So that little star right there is a multiplication sign. So that just helps you read the notes. Upside down V, that means to the what power, and then the star button is multiplication. I'll also remind you that your ALEKS textbook online, even though you of course go there for assignments, you have tons of different materials there that can help you, like different guides and videos and things. And then I'll also mention again to you the Khan Academy. So if you were really struggling, let's just say with the quotient rule, you could type in Khan Academy quotient rule, and I mentioned that last week as well. It was also on the assignment assessment last week to make sure that you were tracking that as a resource. And then that would bring up different videos where you have just many different examples, and sometimes seeing different examples is helpful, especially if you're trying to find one that looks similar to the problem you're solving, and then you can play the video, pause it, pause, and do it at your own pace and intensity. So I like to use steps in my notes for you guys because we want to, for example, make sure that we break things down very sequentially, because it might get overwhelming if you're trying to think about every step all at once. So here, for example, you have steps to simplify expressions with integer exponents. So what are we doing? Well, first, when we're simplifying means you're making it as simple as possible. Again, this is where it's super important to read the instructions, because if you try to solve for x or come up with a number, you're going to be frustrated, because that is not what the point of this is, okay? When it says simplifying expressions, you're simplifying meaning you're getting down to as simple as possible where there's no more moves that you can make. And so it tells you here, for example, identifying like bases. Again, you have to know what a base is. So you can go back up to your vocabulary here. The base is the number being multiplied. So if you had 3 to the 4th power and you wanted to identify the base, 3 would be the base. So that's where the steps to solving and the vocabulary connect. And then you're going to apply the product of powers rule. Okay, where's the product of power rule? Okay, you see power of a power rule, power of a product rule. So you want to go up, and as you are reading through and doing your steps and going through the instructions of assignments, find that vocabulary. And then the power of the quotient, apply the quotient of powers rule. You'll see that that's there. So this is a rule that you'll follow every single time that you solve. That's what a rule means. A rule literally means that. That means you follow this rule every time you solve a math problem that calls for this situation. So every time you are looking at quotient of powers, you're going to look at this rule here. And it basically means anytime you have something that looks like this, it's going to equal what's on the other side. So you can see here that a over b to the m power equals what? So a over b So if you have a fraction, right, a over b, to the m power, which m is like up at the top here, then that means that your a is to the m power and your b is to the m power, okay? So that m power, and it could be a 3, let's just say it was a 3, a over b to the third power means a is to the third power and b is to the third power, and you could put any number in there. So that's the rule you're going to use when you're solving these types of questions. So this is the how of how you can use this vocabulary and these different steps to solve problems. And then I have an example here for you. So again, I socialized this with you last week, and so I'm just going back over it again this week because the more you work the math problems, I think the more clarity you will have on how to use this to be successful. I'm going to shift a little bit because you're going to be very quickly getting into polynomials, and I want to show you what I have here resources-wise for you when you're working with polynomials. Again, going back to, you have to have the basics, right? You have to have the foundations to work polynomials. So instead of just jumping into the problems and trying to solve, I want to give you some of the key elements and concepts. And so we start out with not just solving for polynomials or solving polynomials, but let's just basically define what it is, right? So I'll give you a minute to read here. I'm going to pause for a moment. You can pause the video or you can just pause and read. Okay. So essentially, we're looking at a finite sum of terms, right? So in a polynomial, x is defined as the finite sum of terms of the form ax. So that means a is a real number and the exponent is n. And for each term, a is going to be called the coefficient and n is going to be called the degree of the term. Now, it might sound like I'm speaking a different language to you, and this might be complicated, and it is kind of a different language, right? We said math is its own language. So let's look at some problems and some examples, and then you'll get to kind of come back to this. This is where I think printing out things is super helpful, because you can kind of print out 3 or 4 different things and then look at some problems and go back and kind of match and break it down. I don't even think maybe the basic definitions right here is going to be helpful. I really want to look at some samples, but I will just call out some basic vocabulary. If you remember in school when you looked at the base of language, right, like the prefixes and suffixes, and there was different hints to what a word meant within the word, kind of going back to those Latin roots. So within polynomials, we have monomial, which means there's just one term. Binomial, with bi means 2, so 2 terms, and then trinomial, 3, tri is 3 terms. So I will just bring your attention to that so that when we're looking at these, that you can see the singular, double, or 3-term polynomials. And here's just a way to break this down, right? So remember I said it was like AX is the formatting. So this just gives you some examples of that. Again, I kind of feel like you should probably print this out, look at some problems, and then come back and use this simultaneous to looking at the problems. And then that's just an example of what monomial, binomial, and trinomials look like. So this is one term here. Binomial, you have 2 terms, so you have this one, and then you have this one. And then tri, you have 3. You have the w, the 2w to the 3rd power, and the nw to the 6th power. So that's all that means. It's just you have 3 terms. But let's look at some problems. So this will allow you to kind of see what I'm talking about with that vocabulary and what the problem is asking you to do. So in this one, for example, you're just simplifying. And then the solution, you're writing the expression clearly. You're using those rules I talked about, combining like terms, and then you're writing your final simplified expression. So here you have an expression with 3 terms. So it's a trinomial. And you can see that it's broken down and it's not a number, right? So you're not you're not what do we call it, solving for a number. And then there's a couple of samples here. FOIL, I don't know if you have come across this yet, but just like in basic math, you have PEMDAS, right? So the order of operations. In addition to the order of operations, you have FOIL, which means anytime that you have multiple variables and expressions and they're kind of squished together, you're going to follow this order for solving. So the first, you can see here, so okay, like take this one here, right, 2x plus 3 times x minus 4, and what are you going to do first? You're going first here, you're going to take 2x times x, which is going to equal 2x to the second power. Okay, why? Because 2x here, okay, in your first set of parentheses, this 2x, that's there, times x, so anything butted up against each other, right? So if you had 3x, it means 3 times x. So this whole thing, even though it's more than one variable, there you go, is multiplied times the x. But the first thing we're going to do is take 2x, multiply it times x, which means you have 2 x's, right? X times x. And we know exponents uses the we know it's multiplied times itself, we use an exponent. So now you have 2x to the second power. Remember, this is just your little tiny 2 that goes right there above the x. So the first thing you're going to do is have 2x to the second power. Then we're going to do the same thing, right? We're going to multiply first, okay, using FOIL, the 2x. Now we're going to multiply it times -4, which gives us -8x. Now we're going to do the inner. What is the inner? The inner is a little tricky. It's the inner of both sets of parentheses. So the 3 and the x is the inner. So we're multiplying them together. 3 times x is 3x. And then the last, which means the last numbers in the parentheses. So 3 is the last number here, and 4 is the -4 is the last number there. So 3 times -4 is -12. Now you're just going to combine, right? So you've got 2x to the second power, you've got -x, you've got 3x, and you've got -12. We're going to combine those like terms. So how do we combine them? Just like that. So I'll give you a minute to look at that. And then we simplify. And then there's a couple of more examples here for you. So what I really expect you to do is really work on that productive struggle. This might be, hint, hint, your other second question for your lecture video assignment this week is talking about productive struggle, because that's where you're not going to always be able to solve it the first time, and that's okay. Math is really about persevering and working problems, and you're learning from that experience. So don't get frustrated with the struggle part, because you're struggling to improve your content knowledge and build your confidence. So it's okay if you struggle a little bit as you work through these problems and you build that confidence. So I will post these 4 documents in this video, and I'm wishing you the best of luck this week, and I'm wishing you some patience, and just give yourself time to work these problems. Have a great day.